This is a documentation video for some explorations I did using littleBits for the purpose of thinking about hands-on learning, embodied computing paradigms, and tools for understanding systems. So littleBits is marketed as a STEM toy for kids to build technology projects. It has component blocks that magnetically snap together, like here a power bit goes to a proximity sensor bit that goes to an oscillator that goes to a speaker, so that we can create an auralization of how close my camera is to this sensor. I picked these up because lately my hands have been craving computation. I want texture to my computational experience. Here I used littleBits to make my purse breathe, and the speed of the breath depends on whether I'm petting it or not because the purse is slightly translucent and there's a light sensor in there. The first project I made was to make this sculpture I'd been working on into a kinetic sculpture with the help of some Legos as well, and an alarm goes off when they kiss because the steel completes the circuit to a buzzer. But the first kit I got didn't have many bits, so I picked up more robotics bits and some musical bits, including a sequencer, so I could make this party bus that moves to the beat. And there is also a light sensor so that the pitches don't stay static and it honks more when you get too close and block the light. I modified the party bus a little to make a drawing robot, and I didn't have paper big enough for what it wanted, but I found a way around that. And this robot's motions and sounds are also partly controlled by a light sensor to make it sound more dynamic and give it some drawing rhythms that you can see when it's going slow enough. I also enjoyed that the little keyboard bit can be tuned to microtonal scales if you stick a dimmer in front of it, and I love that anything musical can be made to dance just by snapping a motor onto it. Okay, but what I really wanted to explore are systems. Like here, a light sensor attached to a servo moves a feather back and forth according to the light level, and you can change the sensitivity too. So here, the brighter it is, the further away it puts the feather, so that's pretty stable. But if you flip the mode, then it wants the feather to come closer when it senses light, which then shades the sensor, which makes it put the feather further away, which makes it brighter, which brings the feather closer, and so on. Sometimes it finds its stable equilibrium, sometimes it oscillates a little, sometimes it oscillates a lot, depending on the lighting conditions and sensitivity settings. I also tried using floppy paper instead of a feather to get more delay and chaos to the oscillations, and I attached a paintbrush to create very artsy robot-aided systems art. I find this general idea of easy-to-create hands-on systems examples to be pretty compelling. I'm not sure how far littleBits can reasonably go with it, though. I'd like deeper tools that let you get very complex and also be able to see into the states of the systems and have graphs and abstractions pop up into AR or something. Anyway, my littleBits explorations led to lots of thoughts, and also they helped me think out loud with my hands about some things that have been on my mind, and I wrote about all that elsewhere. So see the description for a link to all the deep thoughts.